Okay, so today we're going to go ahead and go over how to draw Lewis structures for covalent bonds, in other words, for molecules. Okay, so first we're going to go over some background information, then we'll go over the steps, then after that we'll go over some practice problems. So first thing we need to know is the octet rule, which we've gone over already, but essentially the octet rule is going to state that every atom wants a full outer shell. Okay, in other words, it wants 8 valence electrons. So that's the first concept we have to understand. The second concept we have to understand is we have to be able to look at types of bonds and understand, we have to be able to understand what type of bond we're looking at. So when we have something like this, H, this is a single bond, and that represents 2 shared electrons. Okay, so you can think about it as one being there and one being there. So a line represents shared electrons. So for example, if we have this compound here, okay, if we have 3 lines, those 3 lines will represent 2 electrons each line. So it'll be 2 times 3. This represents 6 electrons. Okay, you can think about it as having an electron here, 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 and here, right, to give us a total of 6. And those are being shared between the 2 atoms. We also have these electrons here, these pairs that are not shared. That's what we call lone pairs. They are pairs of unshared electrons. So they are only belonging to this element. They're not being shared with the other ones. Those are lone pairs. Okay, that'll come in later, but I did want to bring it up now. Last thing we have to be able to do is we have to be able to find total valence electrons. So we have to be able to find total valence electrons. So let's look at some examples, and then we'll go ahead and start doing this. So let's look at N2. If I wanted to figure out how many valence electrons are in this compound here, well, first we have to look at nitrogen. We know nitrogen has, if we look at here, nitrogen has 1, 2, 3, 4, 5 valence electrons, right? So nitrogen has 5 valence electrons, but we have 2 nitrogens, so we'll multiply that times 2. So this would give us a total of 10 valence electrons. Okay, let's look at another compound. What about carbon bonded to nitrogen? Carbon has 4 valence electrons. Nitrogen has 5, so we add them up, right? Here I could have added them up, so it could be 5 plus 5, I just multiply, same thing. But basically we're just trying to find the total valence electrons. So this would give us 9 valence electrons. Okay, all right. Now let's go ahead and do another example. Let's say we have C2H2. So we know carbon has 4 valence electrons, right? So for carbon we would have 4 valence electrons, but we have 2 carbons, so multiply times 2 would give us 8. Then we have hydrogen. Hydrogen only has 1 valence electron, but we have 2 of them, so it would be times 2, 2. So this compound would have 10 valence electrons, and so forth. Okay? So essentially we find the total valence electrons by just multiplying each one by their total number of their individual valence electrons. All right, let's go ahead and go into the steps on how to draw Lewis structures. Then after that, we're going to go and do some practice problems. So here are the steps. So first, we find, and I'm going to leave this here if you guys want to copy it, but we're going to be using these. You don't have to memorize these steps because we're going to be using them so often that you should become a little bit familiar with them. Okay. So step 1 is find the total valence electrons. So we should know how to do that. We just did that, right? 2, we place atoms in their appropriate locations. Typically, my least electronegative is going to go in the center. That's not always the case though, but it's a general rule. And hydrogens, even though hydrogens are the least electronegative, those are exceptions. Hydrogens always go on the outside of an atom. We'll look at that in a bit. Step 3, draw individual Lewis structures. We know how to do that. We did that in the first couple of weeks of school. Step 4, connect unpaired electrons. And step 5, check the octet rule. Make sure everything has a full outer shell. So let's go ahead and look at some examples here. All right. We'll start with a very simple example and then work our way to something a little bit more complex here. So keeping these rules in mind, I'm going to go ahead and do a couple of problems here. Okay. So the first problem, we're going to go ahead and do a Lewis diagram for hydrogen chloride. So hydrogen, different one here, hydrogen chloride. Okay, so step 1, find the total valence electrons. Okay, well I know hydrogen has 1, chlorine has 7, so the total is 8 valence electrons. Okay, we do this in the beginning to check at the end, so I'll show you guys. Okay, all right. Step 2, place the atoms. When we only have 2 atoms, you actually can skip part 2. You don't have to worry about placing the atoms in a certain order because we only have 2. There's only one way we could put it is hydrogen, chlorine. Okay. Step 3, draw individual Lewis structures. Well, I know hydrogen has 1 valence electron. So I'm just going to go ahead and draw 1. I know chlorine has 7. So I'm going to go ahead and put 7 using the cross method that we've done before. So 1, 2, 3, 4, 5, 6, 7. Okay. If we notice, there's going to be unpaired electrons, which goes on to step 4. We want to connect unpaired electrons because these are in pairs, these are in pairs, these are in pairs, but this is not a pair and this is not a pair. Electrons don't want to be by themselves, they actually want to be in pairs. So they're going to go ahead and share these 2. So we draw a line to represent the sharing of those 2 electrons. So that's step 4, connect unpaired electrons. And then typically if some models, we would redraw them to make them look a little bit cleaner. So HCl, that'd be our final structure. Okay. Last of all, check my octet rule. So hydrogen they're sharing these, so hydrogen has 2 around it. Okay. So that's full, only for hydrogen. So that's good. Chlorine has 1, 2, 3, 4, 5, 6, 7, 8 around it because these 2 are being shared. So that's good. That structure is correct. Okay. All right. Then the last of all, we can check, is our total valence electrons correct? Well, yeah, we have 8, right? We have 1, 2, 3, 4, 5, 6, 7, 8. That's correct. So our diagram is correct because our diagram should show the total valence electrons because that's what Lewis diagrams do. All right. So when it's a little bit more difficult, I have carbon and bonded to 4 hydrogens here. All right, we're going to go ahead and go through the rules. So step 1, find my total valence electrons. Well, carbon has 4, and then plus hydrogen, which has 1, but times 4. All right, so this is going to be 4 plus 4. So we should have a total of 8. Okay, so we have 8 total valence electrons in this compound. All right, so step 2 is going to be, we're going to go ahead and place the atoms in the correct order, right? Well, we know hydrogens go on the outside, so we're going to go ahead and put carbon here. So we're going to put carbon, and hydrogens tend to go on the outside of this compound. And after a while, you'll see kind of how they're arranged, and you'll get used to it. All right, so now we know we want to go ahead and draw the individual Lewis structures. Well, carbon has 4, so we're going to go 1, 2, 3, 4. Okay, each hydrogen has 1. 1, 2, 3, 4. All right, so that's pretty easy. Well, you should see the trend already. This is unpaired. This is unpaired. They're going to pair up, unpaired, unpaired, pair up, unpaired, pair up, and then last of all, pair up. Okay, we're going to go ahead and redraw this a little bit neater here. Carbon, H, H. This would be my final Lewis structure. Now let's double check the octet rule. Every hydrogen is sharing 2, so they're all good. Okay, carbon has 1, 2, 3, 4, 5, 6, 7, 8 around it. So carbon's happy, has 8, it's good. Okay, and last of all, do we have 8 valence electrons? Yes, we do, because we have 4 lines. 4 lines times each one has 2. 4 times 2 gives us 8. Okay, this would be correct. All right, let's go ahead and do one that's a little bit more complex here. So let's look at O2. All right, so oxygen has 1, 2, 3, 4, 5. Let's see, 1, 2, 3, 4, 5, 6 valence electrons. 6 valence electrons. We have 2 of them, so we should have a total of 12 valence electrons. Okay. All right. So let's go ahead and do this model here. First, we counted the total. Second, place the atoms. Well, we only have 2 oxygen, so we don't have to worry about how they're going to be placed, because when you only have 2 atoms, we don't have to worry about what goes in the center. Okay. Now let's go ahead and do step 3, which is draw individual Lewis structures. We know each one has 6, so you're going to go ahead and put 6 doing the cross method. So 1, 2, 3, 4, 5, and 6. Right? Same thing here. 1, 2, 3, 4, 5, and 6. All right. So now we want to go ahead and pair electrons that are not paired. So here we have that's not paired, right? That's not paired, and that's not paired. So we're going to go ahead and let's connect these 2 first. So that is not paired, right? If you were to just leave it like this, you would see that it would be incorrect, because actually we'll go over this at the end, but this would be incorrect because not everything would have a full valence electron. Okay, so let's go ahead and connect these. This is unbonded, that's unbonded, so that's going to connect as well. Okay, so if I were to draw this a little bit neater, this tells me that I have a double bond between those oxygens. So I have oxygen, double bond, oxygen. And then I'm just going to carry these electrons over here. Same thing, carry these electrons over here, right? So let's go ahead and see, does everything have 8 around it? Well, this oxygen has 1, 2, 3, 4, 5, 6, 7, 8 around it, so that's good. The other oxygen's the same, so it would be good as well. Okay, does it have 12 valence? Let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good, my structure is correct. Okay. If I were to have only left 1 bond, and it would have looked something like this. Would have looked like this, in which we had 1, 2, 3, 4, 5, 2, 4, 5. Okay. Why would this be incorrect? Well, first, let's count the total number of electrons. This one has 1, 2, 3, 4, 5, 6, 7. That is why this is incorrect. It does not fulfill the octet rule. Remember, and things don't want to be unbonded, so that's why they end up bonding. So that is incorrect. So that's our model. All right, let's go ahead and look at another one here. All right. This will be the last one. Slightly more complex, but still not too difficult. So here we're going to have carbon, so a CH2Cl2 compound. Okay, so first we have, again, find total number of valence electrons. Carbon has 4, plus each hydrogen has a 1, so it would be 1 times 2, in other words 2, plus chlorine has 7, okay? But we have 2 chlorines, so 7 times 2 would give us 14. So in total, we should have 6 plus 14, that is 20 valence electrons, okay? And we do this to double check at the end. All right, so now let's go ahead and go on to step 2. How do we place these atoms? Well, we know hydrogen goes on the outside. Then we have chlorine and oxygen. Which one's the least electronegative? That's going to be carbon. So carbon goes in the center. Also, another thing to remember, typically carbon always goes in the center because carbon likes to form 4 bonds. So it wants to go in the middle of things because it can form a lot of different bonds. So I'm going to go ahead and put carbon, hydrogen, and then my other chlorines around here. Chlorine. You could also go chlorines here, hydrogens here, or chlorine. It really doesn't matter. Okay, the order of these, as long as they're on the outside, it's fine. All right, let's go on to the next step. Draw individual Lewis structures. Well, I know each hydrogen has 1, so 1, 1. Each carbon has 4. 1, 2, 3, 4. Each chlorine has 7. So make sure we do the rule. 1, 2, 3, 4. 5, 6, 7. Okay, 1, 2, cross method, 3, 4, 5, 6, 7. All right, so this is unbonded. We're going on to step 4. Unbonded, they bond. Unbonded, they will bond. These two are unbonded, they're going to bond. Last of all, these two are unbonded, and they will bond. Okay, then I want to go ahead and clean this structure up. I want to redraw it. So I know I have carbon with 4 bonds around this. I have carbon bonded to a hydrogen, to another hydrogen, to a chlorine, to a chlorine. Okay, don't forget to bring these electrons over. And that's my final structure. Okay, I can double check. Carbon has 4 lines around it. Each line has 2, so that's 8 electrons. It's happy. What about chlorine? Chlorine has 1, 2, 3, 4, 5, 6, 7, 8. Yes, it's good. So everything has the octet rule. And if I were to count the total valence electrons, it would be 20. So my structure is correct.